We're going to take a look at some logarithmic equations. Log equations will basically boil down to one of two types. If you have a single log, that is, if you have something that you can get down to be in the form of log base b of y equals x, what you want to do is switch it back into exponential form, that is, rise b to the x equals y, and take it from there. The other form is that if you can get it down to a log on each side, by the one-to-one property of logarithms, you can just drop the logs. All right, so once again, if you get it down, you have it down to one log, write back in exponential form, work it out from there. If you have a log on each side, drop the logs, set what's inside equal to each other. So let's take a look at some different examples. Say I have log x plus 2 equals 3. Notice that there is no base written there, but do you remember what the base would be? It's 10 because it's a common log. All right, so the 10 is implied as being there. All right, so write this back in exponential form. I can write 10 to the third equals x plus 2. That is 1,000 is x plus 2, and so x subtracting 2 is 998. I have 4 log base 3 of 2x minus 1 is 7. All right, this isn't immediately in the format. I just want to get this log by itself. All right, so I'll do a little bit here. That is add the 1 and divide through by 4. So I got 4 log 3 of 2x is 8. Come up here, log base 3 of 2x is 2 from dividing through by 4. Now I write an exponential form. That is, I got 3 squared is 2x. Remember, logarithm is an exponent, so this is a part that's by itself. So 9 is 2x, and so x is 9/2. All right, so I got log base 2 of x plus 2 plus log base 2 of x is 3. Here I have 2 logs, and it doesn't make sense to put the other one over here. You got this 3 there. So what you want to do is to write this as one log. That involves property. When you have sum of logs, we can put that together as the log of a product. Now, I have log base 2 of x squared plus 2x equals 3. And let's write back in exponential form. So I have 2 to the third is x squared plus 2x. 2 to the third is 8. Now, we can see that this is quadratic. So I want to set equal to 0. So I have 0 equals x squared plus 2x minus 8. Then let's go and factor. So I want to come with two numbers that the product is negative 8, the sum is positive 2. So I got plus 4 and minus 2. Saying each of these equals 0, I got x equals negative 4 or x is 2. Now, it ends up that the only answer here is x is 2. Negative 4 doesn't work out. What you have to do is to check it back into the original. Remember that the domain for a logarithmic function is all positive values. So if you put a number in here and you get the log of a negative number, log of 0, you got to throw it out. Okay, so when I put negative 4 back here, this is negative, so that didn't work out. So I just have x equal 2. All right, so several different things going on here. Remember that the log of a plus log of b is the log of a times b. So when you have a sum, together is a product. Just like when you're working with exponents. When you multiply, you add the exponents. All right, so then multiply this out, write back in exponential form, and take it from there. This one, you can see has a difference. The other one was a sum. This one's a difference. So this is another property. That is, when you have a difference of logs, right, there's a log of a quotient. Notice this is just plain old log, so that's log base 10. So 10 squared equals x over x minus 2. 10 squared is 100. Go ahead and multiply through by x minus 2. That is, we multiply both sides through by the denominator. So I got 100 times the quantity, x minus 2 is x. So 100x minus 200 is x. So I got negative 200 equals negative 99x, bringing over the 100x, dividing through by negative 99. X is 200 over 99. All right, so the difference of logs, remember, is a log of a quotient. All right, notice on this one, this is the other type. I can't drop the logs right away, okay, because I got two logs over here. Remember, when you have a log on each side, you can drop the logs by one property. But what I can do is I can go ahead and bind these. This is a product, because remember, this was sum, so I got the log of x times 7 minus x. Now I can drop the log. So I got 12 equals x times 7 minus x. 12 is 7x minus x squared. All right, so it's quadratic again. Let's bring this back over here. I got x squared minus 7x plus 12 is 0. Factoring. Two numbers of products 12. The sum is negative 7, negative 3, negative 4. So we get x is 3 or x is 4. All right, so the solution set can consist of more than one value. Both 3 and 4 make up the solution set. Natural log of x plus 2 minus the natural log of x minus 10 is a natural log of 2. This is a difference again. So we put that together as a quotient. Natural log on both sides. Let's drop the natural logs. Go ahead and multiply through by the denominator. So I have 2 times the quantity, x minus 10. Oops. Okay. So I have x plus 2 equals 2x minus 20. And let's see, let's bring the x over here, bring this back over here. So I get that x is 22 from subtracting x and adding 20.